relation between electric field and potential. For this, we are going to draw a diagram. Like always, each derivation starts with a diagram. The positive charge, let us call it as plus Q, and it is kept at the origin. Then at some distance from the origin, we have got 2 points, and we are going to have an electric field. This is the direction of electric field, and this is point A, this is point B. We have, this is origin, and this is the positive charge plus Q placed at the origin. And by the logic, we are going to have some potential at point A and some potential at point B. Let us say at point A, the potential is V, and at point B, the potential will be slightly more because point B is slightly closer to the charge compared to the charge A. So this is going to be V plus dV. So there will be small value of voltage or the potential slightly more than the potential at this point A. So the distance between these two, it is a small distance that will be labeled as dr. Immediately after the diagram, we need to explain the diagram. The explanation will be, consider an electric field E. Why this is existing? Because of the charge plus Q placed at the origin. So we are going to consider an electric field which is produced by this charge plus Q which is kept at the origin. Let A and B be the two adjacent points. They are nearby points along the line along which the electric field is passing, and they are separated. AB, the distance is potential at A, it is V, and potential at B, it is V plus dV. So we have two different potentials at the two different points, that is A and B, which are along the line through which the electric field is passing. To move the test charge which is coming from infinity, and we are trying to move that test charge from A to B. Now, if we want to move that electric charge or the test charge from point A towards point B, means I need to do some work, because point A is at a different potential and point B is at a different potential. So to move against the electric field, I need to do some work, a force, and that force will be given by Q naught into E. What is this Q naught? Q naught is our test charge which we are going to move from point A towards point B, and E is the electric field, and the direction of the force with which we are going to move the charge between A to B is opposite of the direction of electric field. So we are going to take a negative sign with that equation. So what we are doing, we are trying to move the test charge from point A towards point B, and the electric field direction is in the opposite way. So this force is going to become opposite to the electric field. The work done in moving Q naught from A to B, that will be W equals to F into dr, because work done is force multiplied by displacement. Force, we have it here, which is minus Q naught times E, and the displacement is between A and B, and that distance is given by this dr. Now I have the value of this force from this equation. I can substitute this value here in the place of force. So this is now going to become minus Q naught E into dr, and that will be my equation for the work. Now we know that work is a scalar quantity, so this will be a dot product, and the result of the dot product for the angle which are going in the opposite direction, it will be 1. So this I'm going to just take it as just as the magnitudes of those things. So it is going to be minus Q naught E. The potential is the work done in moving a unit positive charge against the field. Also have what we have here is W can also be written as Q naught into VB minus VA. So potential multiplied by the charge which we are going to move. So that is again going to give us the work, because ultimately what is the definition of potential? V is equal to W divided by Q naught. If I want W, it will be Q naught into V. What is V? V is the potential. What is the potential here? It is the difference of the potentials at point A and point B. So we are going to take it as VB minus VA. Now I can substitute the values of VB and VA which are available here. So Q naught into, what is VB? It is V plus VB minus of V. And from this equation you can directly, the V is gone. What is left is only dV. So W is equal to Q naught into dV. This I can call it as equation number 2. I have got equation number 1, equation number 2. Both the left hand sides are same. So I can equate the two equations. So equating 1 and 2. What I have in equation number 1, it is minus Q naught E dr equals Q naught into dV. So immediately I can cancel this. Q, we have the electric field on the left hand side. We have the potential on the right hand side. Just shift everything except for this field onto the right hand side. So what we are going to be left with? E will be here. All else, what are the other things? There is a minus sign remaining here. There is a distance dr remaining here. These two will be shifted towards the right hand side. This is going to become E equals minus dV by dr. And this relationship is called as the relation between electric field and the potential. This term on the right hand side, dV by dr. This term is called as potential gradient. Potential gradient. So in words, if I want to say, it will be said as electric field is negative of the potential gradient at that point. So what is electric field? Electric field is equal to the negative potential gradient at that point. So that term dV by dr is potential gradient. One thing before I go, the electric field, we have the unit is defined as Newton per Coulomb. Alternatively, after this derivation, we will have the unit volt per meter, because dV is the difference in the potential which will be measured as the unit of potential, which is volt, and dr is the displacement which is measured in terms of meter. So we can use either Newton per Coulomb or volt per meter. Both are going to have the same meaning. So Newton per Coulomb as well as volt per meter.